You're welcome to Eureka Tempus, and in today's episode of Introduction to Physics, we'll be looking at physical quantities. Do not forget to like the video, and if you're visiting for the first time, subscribe to our channel and hit the notification bell so that you'll be notified when subsequent videos are uploaded. At the end of the lesson, students should be able to define physical quantities, list the types of physical quantities, define fundamental quantities, list and define the seven fundamental quantities, define derived quantities, list examples of derived quantities. Let's dive into the concept of physical quantities using something we are familiar with, that is human attributes. Think about yourself or someone you know. We all have characteristics, right? Some of these characteristics can be measured, like how tall we are, how much we weigh, or how old we are. Other characteristics like kindness, creativity, sense of humor, and beauty cannot be measured in a standard way. We cannot measure our kindness with a ruler or scale, and of course, beauty has always been in the eyes of the beholder. On the other hand, height can be measured in feet or meters, weight in kilogram or pounds, age in years, months, weeks, days, etc. So, as a human, you have two attributes. The first are the immeasurable attributes, and the second is the measurable attributes. Just like humans, other things have their own attributes, which we can also call characteristics. Some of these attributes can be measured, and some are immeasurable. For instance, the leaves of a mango tree is green, but this green color cannot be measured. However, the tree have other attributes which can be measured. For instance, its height or even its age. You must have heard of a tree that has stayed up to 10 years, 20 years or thereabouts. Also, the universe has many attributes. Some of the attributes are measurable while others are not measurable. The mass of the earth can be measured. The surface area of the earth can be measured. These measurable attributes of humans, the tree, and the universe are similar to physical quantities. Just as we can measure our attributes such as height, weight, or age, in physics, we can measure length, mass, and time. When we measure these attributes, we get a clear and precise way to describe them. That is exactly what we do in physics when it comes to physical quantities. We measure them so we can refer to them in a precise manner. Therefore, we can define physical quantities as the attributes of an object or phenomena that can be measured, quantified, and given a unit. Now, let's take this understanding further by exploring the types of physical quantities. In physics, physical quantities are categorized into two main types: fundamental quantities and derived quantities. Let's break it down in a simple and relatable way. The digits 0 to 9 form the foundation for all numbers we use. These are the simplest, most essential digits that we cannot break down into anything simpler. For example, the digit 1 is just 1, nothing more, nothing less. You can't break it into a simpler digit. This is the same with the rest of the digits from 0 to 9. It is from the digits 0 to 9 that every other number, such as 10, 11, 12, 13, 14, 16, and so on and so forth, are formed. The digits 0 to 9 can be said to be fundamental because they are the basic digits upon which every other number you can think of is formed. Why 11, 12, 13, 14 down to 29 can be said to be derived because they are formed by a combination of two or more of the fundamental digits. Same thing with our English alphabet, the 26 English alphabet we have. They are the basic building blocks to every form of word you can think of. Any word or every word is formed from the 26 English alphabet. So the 26 English alphabet are said to be fundamental because every other word is formed from the 26 alphabets. Now, relating this to physics, Fundamental quantities are the basic quantities that are independent of other quantities and cannot be derived from them. They are the basic quantities upon which most quantities depend. There are 7 fundamental quantities, including length, mass, time, temperature, current, luminous intensity, and lastly, amount of substance. Now let's look at them one after the other. Imagine you are measuring the distance between 2 points. It could be the distance between 2 poles, distance between 2 trees, or maybe you are measuring a goalpost. The space between those 2 points A and B is what we call length. Therefore, length is a measure of the distance between 2 points. Number 2, mass. Imagine picking up a bag of cement and then holding your phone. You will quickly notice that the bag of cement is much harder to lift because it has more mass. It is made up of more matter, making it heavier. On the other hand, your phone is much lighter because it has less mass. Therefore, mass is a measure of the quantity of matter in a body or object. Number 3, time. It's sunrise in the morning, and in some hours later it will be sunset. This is an observable phenomenon in our everyday life. What is responsible for this event? Time is the answer. Time is that which describes the sequence of events and the intervals between them. We can define time as the measure of the duration between events. It is that in which events are distinguishable with reference to before or after. Number 4, temperature. Imagine you are holding a cup of tea on a cold morning. The warmth you feel from this cup of tea is due to its high temperature. It has a lot of energy. Now think about touching a cold can of Coke or Fanta on a hot afternoon. The chill you feel is because the soda has a lower temperature. It has less heat energy. Temperature, in simpler terms, tells us how hot or cold something is. Therefore, we can define temperature as the degree of hotness or coldness of a body. Think of a river that is flowing. Just like how the water flows from one place to another, an electric current is the flow of tiny particles called electrons through a wire. Now imagine you have a battery and a light bulb connected by a wire. When you switch it on, the current flows through the wire like water in a river, making the light bulb glow. So electric current is simply the movement of electricity from one place to another, powering things like your phone, televisions, and lights. When choosing a light bulb for a room, people often focus on how well the bulb will illuminate the space. This perception of brightness, which our eyes dictate, is influenced by a phenomenon called luminous intensity. Luminous intensity is the measure of the brightness of light emitted by a source in a particular direction. Number 7, amount of substance. When preparing a soup, you follow a recipe that specifies the amount of each ingredient. You don't want to taste a soup that is too salty or spicy. Therefore, specific quantity of ingredients are needed to achieve this result. In this case, a delicious soup. Just as precise measurement is essential in cooking to ensure the right taste and texture, understanding the amount of substance helps to ensure the right chemical proportions, leading to successful reactions or products. Amount of substance measures the quantity of entities like atoms, molecules, etc. in a sample. Having known what fundamental quantities are and their examples, we now dive into derived quantities. Derived quantities are physical quantities that can be expressed in terms of the fundamental quantities. They are obtained by some simple combination of the quantities. Examples of these quantities include area, volume, force, speed, velocity, and acceleration. We have many of them which we would explore in our subsequent lessons. In conclusion, we talked about physical quantities, and we say that physical quantities are attributes of an object that can be measured, quantified, and given a unit. We say that we have 2 types of physical quantities. the fundamental quantities and the derived quantities. And we noted that fundamental quantities are the basic quantities that are independent of other quantities and cannot be derived from them. We listed 7 examples of fundamental quantities, which include length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Then we said that derived quantities are quantities that can be expressed in terms of the fundamental quantities. They are obtained by simple combination of the fundamental quantities. Examples of derived quantities include volume, area, force, speed, velocity, and acceleration. There are many of them. We will see them in the subsequent lectures. Thank you and God bless you.